This is part 2 for electron configurations and how it relates to the periodic table. We've already done the s orbitals, so we know the s1s are group 1. We know that the s2s are group 2. And then we've got p1 all the way through p6 in our p block here. So that's 1, that would be 2, 3, 4, 5, and 6. So we have 2 more orbitals to consider, and they are the d orbitals and the f orbitals. The d orbitals are the ones in between the s's and p's. And those are known as the transition metals. And there's a reason. Let's put our numbers on the periodic table again. 1, 2, 3, 4, 5, 6, and 7. The d orbitals start in the 4th period, but they start with 3d1 and then 3d2 all the way through 3d10. So this would be d3, d4, d5 all the way through d10. I use letter D to say these exist along the diagonals between the p orbitals. That's a good way to describe it. But they're the transition metals because they are in transition. They're in the 4th period, but only in the 3rd level for the D. Likewise, for the 5th level, or for the 5th period, we would start with 4d1 and then count all the way through 4d10. So there are 10 total electrons that can exist in the d orbitals. Now what about their dot diagrams? Well, the 3 never appears in the outer level because the 4 would have filled first. So there are 2 dots, okay, for the S2 column here. But when we go to the D elements, there will be 2 on all of them. So those are their dot diagrams. And again, because the 3D will never appear in the outermost level, the 4S that was filled first, okay, would be higher up than the 3D. Then when you get to the p orbitals again, you go back to filling in. So we go 1 dot, 2 dot, all of these have 2, then it goes 3, 4, 5, 6, 7, 8, like before. Okay, now what about f orbitals? Well, f orbitals exist down here. Okay, they actually start in this location here, and then after this one you go down to here. Okay, and this one here you go down to here. Okay, that kind of thing. Okay, but they are actually, these are all f orbitals. They start in the 4f. So this is 4f1. And you count all the way through 4f14. Okay, and then this guy would be 5f1. And counting all the way to 5f14. So this would be 4f2, 4f3, 4f4, etc., all the way to 4f14. And this would be 5f1, 5f2, 5f3, etc., all the way to 5f14. Now they are inner transitions because they're twice out of order. Okay, this one is the 5d1 electron location. Then you go down to 4f1. So notice it goes 6 down to 5 and then down to 4. Here we have 7s2, then we go down to 6d, then you go down one more to 5f. They are twice out of order, and that's why they're called the inner transitions. Okay, now these of course will all have 2 dots as well because the 4f certainly is not going to be in the outer level either. So I guess I'll finish this up. All of these have 2 dots and they're paired, again because the outer s level would have filled before them. And that's the pattern. Let's practice a couple. So we go to this. This element here is element PT, platinum. Let's find it on the periodic table. Okay, I see that it's right here. Okay, so let's do our numbers. This is 1, 2, 3, 4, 5, 6, and 7. Okay, there's platinum. Okay, this is a 6s2. Now we need to drop down to 5d1, 2, 3, 4, 5, 6, 7, 8. Okay, so let's go back. Platinum would be a 5d8. And its dot diagram would be 2 dots. So all the transition metals and intertransition metals will have 2 dots and they are paired together. Okay, let's find plutonium, element Pu. We're going to find that down here into the transitions, okay, or the inner transitions, okay. And let's count. We're going to count with, we don't count these two. This is the first one here. So it's a F1, 2, 3, 4, 5. Okay, but we're studying the 4 Fs here and the 5 Fs because remember they're twice out of order. So again, don't count these two. These two, this one's up there and this one's up there. This just shows once you go here, you go down to this next. So it's 1, 2, 3, 4, 5. So this is a 5 F5. So let's write that. So that would be 5 F5. And again, 2 dots. That would be its electron dot diagram. And that's how you handle the F orbitals and the D orbitals. So F can have a total of 14 electrons and D can have a total of 10 electrons.